Now, these three clear signposts to the future, the human population explosion, the century of greenhouse warming and the rising atmospheric content of greenhouse gases, are not really separate problems at all, but very closely connected. Look at the population graph once again. What happened in the middle of the 18th century was a convergence of several things. First of all, living standards were rising, not for everybody, but for enough. The second thing was that the colonization of America began in earnest. Millions of Europeans went to find an enormous ecological opportunity. And then there was the Industrial Revolution, an enormous change in the way we live and produce. And part of that was triggered by simply running out of wood for industrial use and switching to coal. See, what we're doing when we burn fossil fuel is releasing solar energy which has long been buried under the ground. All the fossil fuels are the residues of organisms that lived on the Earth typically hundreds of millions of years ago. When we pump them up and dig them up, we combine them with atmospheric oxygen, we capture the energy and we release the gaseous products of combustion into the air. Now it so happens that these are invisible. They don't smell, we can't see them. And so we've been releasing enormous quantities into the atmosphere for a long, long time, not realizing until very lately that it was doing any harm. Most of the product of combustion is carbon dioxide. And everybody knows by now that carbon dioxide is a problem, but why? I'll just show you now. CO2 is just one of a number of gases that have the same property. They can trap Earth's radiation. This is roughly how it works. Sunlight passes straight through the air. These gases have no effect on that because sun rays have a different wavelength. But the Earth is warm rather than hot like the sun, and it radiates at infrared wavelengths, and those rays smack into greenhouse gas molecules in the air, which become energized and eventually re-radiate rays of their own. And in this fashion, infrared is trapped in the atmosphere. Eventually some rays reach the top and are lost into space. But in the meantime, the heated atmosphere down below is what keeps the Earth warm. It's just the same as adding a blanket. The strength of the effect is determined by the amount of gas in the air, and the concentration on Earth has been going up very steadily. In fact, this rate of increase is unprecedented. No student of climate history has ever discovered anything comparable to what we're doing. Just to give you an idea of how much and how fast this has been changing, here are a couple of graphs from the IPCC 2007 synthesis report. This shows you what's happened to the CO2 over 10,000 years. Now you might wonder how we could know how much CO2 was in the air 10,000 years ago. Well, it turns out there are actual air samples from that age stuck in the ice in Greenland and Antarctica, and they can be recovered in ice cores and measured directly. These are precise measurements, there's no problem with that. But look how steep and rapid the modern rise has been, from 280 parts per million in 1800 to 390 today. This shows where CO2 has been for the last 400,000 years. This is taken from an Antarctic ice core drilled near the Russian base of Vostok. Turns out that modern rise is unique not just in hundreds of thousands of years, but in tens of millions. This is methane, another powerful greenhouse gas, not as prevalent as CO2, but sharply affected by human activity. In fact, in percentage terms, methane has risen much more than CO2. And this is nitrous oxide, a greenhouse gas produced particularly by modern industrial activity and the use of nitrogenous fertilizer. So the situation we've created for our grandkids is one of a crowded world and a hot future. Now, if you've been interested in this issue, most people have, you'll have heard people say, well, so what? A little bit hotter, we can cope with it. A couple of degrees, it doesn't matter much. Well, I want to tell you that the answer to the question, does it matter, is yes, it does. It matters a lot. It's probably the biggest problem that humanity has ever faced. That's a big claim. It's capable of doing as much damage as a flat-out nuclear holocaust. How can we know this? By looking at the Earth's climate history. That's what we'll do now. This isn't a particularly easy thing to represent on a diagram, but it tells a story without which it's a bit hard to understand exactly the meaning of our present situation. So bear with me a minute, I'll try and explain what this shows. It's a temperature record of the Earth going back the enormous period of 75 million years. This wiggly black line is the temperature record, and when it hits the bottom at the present, it turns red and then jumps up like that. This arrow separates the past from the future. You can see that in the past the numbers represent 20 million years, and in the future they represent 1, 2, 3, 400 years. The red line is actually the IPCC's projection under the circumstances where we don't do very much about keeping CO2 down. Across the bottom is present temperature, and then there's a temperature scale going up the right side. Here is where an asteroid smacked into the Earth and caused an event which extincted the dinosaurs. This one is a thing called the PTM, a sudden warming event which is probably caused by the release of a very large amount of submarine methane. Here is a very significant turn of events. Some cooling event caused the temperature to drop over a boundary and trigger the formation of the first permanent ice sheets in the Antarctic. For 20 million years, the ice sheets behaved dynamically. They shrank and grew depending on variations in the climate and other factors. And then 14 million years ago, they became permanent and began to resemble the ice sheets we know now. 3 million years ago, after another cooling event, ice grew in the northern hemisphere for the first time. The two things I'd like you to take away from this little story are these. Here is a 1-degree boundary between an ice-free northern hemisphere and the northern hemisphere we know. At 3 degrees warmer than the present, an enormously significant boundary appears to exist between an ice-free world and the one we know. In this part, tropical plants grew in Alaska and indeed in Antarctica itself. So this is an entirely different planet, not just a little bit warmer than the world humans have known, but more like the world the dinosaurs knew. Now we're going to just focus down on the last 5 million years here to see a lot more detail. Here it is. This has been reversed. The present is over on the left, the past on the right. This is the era we know as the Pleistocene Ice Ages, 3 million years long, where the climate has this jagged character with many ups and downs. This is the time when humans have existed on Earth, 2 glacial cycles, and this is where the northern ice sheets were born 3 million years ago. The thing to notice about this record is that the jagged character is not an artifact of a rough record, but records true events. For reasons that are not completely understood, the presence of ice in the north acts as a kind of amplifier, and small triggers therefore set off very abrupt and large climate changes. This has been a most important discovery with enormous implications for what's happening in our future. And the last thing is that 1-degree boundary, which is there again. Above that, all the northern ice melts and Earth loses its ice mirror and its northern refrigerator and becomes a completely different planet, with sea level 5 to 10 meters higher. And this is focusing down on the 10,000 years or so, the entire period of human civilized experience. 2004 representing current temperature sticks out a mile.